Jayendra, Namaste. My name is Sayim Jain. Welcome to my channel. Today we are going to solve the 28th question of the problem solving series, which is based on arrays. So the question is search in a 2D sorted matrix. The difficulty level for this question is medium, and this question has been asked in Adobe, DirectType, Paytm, Amazon, and a lot of other companies. So we are given a matrix, and we need to search the target number, whether it is present in the matrix or not. So this matrix is a sorted matrix. The rows are sorted, the columns are as well sorted as well, and the first element of the any matrix is always less than the previous row of the matrix, right? For example, this 5 will always be greater than the previous row. The 9 will always be greater than the previous row. In other words, we can, if we convert this 2D matrix in a single sorted array matrix, all the elements will be sorted if we travel row wise, right? So we need to find the target element, whether it is present in the matrix or not. If it is present, we will return true, otherwise we will return false. So how do we solve this? Simple. The first approach that comes to our mind is we will do a linear search in this 2D matrix, and if we find it, then we will return it here. If we traverse it like this, see all the elements traverse in a 2D matrix, and if we find it, we will return true. So here the answer will be true. And if we travel in the second question, the target is 50. If we travel it, if we don't find it, we will return false. Here the element is not present. So in this way, what would be the time complexity of the brute force approach? Simple search in the 2D matrix. So the time complexity will be order of n square. So is it an optimal one? Of course not. So what is the information that has been given to us? The elements are sorted, row wise as well as column wise as well, and the current any row's first element is always greater than the previous row's first element, right? So we need to use this information to solve the problem in an optimal way. How do we do it? So if we are given a single D array, 1D array, and if we need to search an element, how do we search it? We search it, we traverse the elements and we search it. But if the array is sorted, then how can we search the elements? We do the binary search. I hope everyone knows about the binary search, right? Low, high, mid, and we exclude the first half, get the if it is not present, then go to the second half, normal divide and conquer approach. And the time complexity of binary search is order of log n. So how do we solve this? So if we see in this first row, can we use the binary search in this first row? Because this row is sorted, right? So how do we use it? We know the first element and the last element, right? So is there any point of doing binary search in every row? If we do a binary search in every row and we find it, what would be the time complexity? So it would be n, if here in this case n is the number of rows, so number of rows into log of number of columns, log of m. So n into log of m, we can find the elements, right? But do we need to do a binary search on all the elements, all the rows? Do we? We don't, right? We will come to know whether that element is present in the row or not. How we will come to know? For example, 8. If this element is present in this row, then this 8 must be greater than 1 and must be lesser than 4, right? Lesser than equal to 4. Then only it is possible that this element is present in this row. But in this case, it is not. So when we traverse the array, we will check, we will just traverse the row and we will see whether this target can be present in the row or not, by checking whether it is greater than the first element and lesser than the last element, okay? So that search will be in n times, okay, max. We can traverse n row is there. If we find out in any row, if we need a binary search to find the element, so in that case we will use this, for example here. So here we did not do binary search. When we came to know, we saw that this first element and last element in this comes in that target comes in this range. So we will start doing a binary search and it will be log of n. So here we can optimize it further. Here we have got that the last element is the target. So here the first element and the last element we can have a check. So in any way, the worst case would be time complexity would be n plus log m. It would be a one of the better approach. So from n square time complexity we have come to order of n plus log m, right? Number of rows plus log of number of columns. Can we optimize it further? So I am not going to quote these two approaches. This is the first one is very simple linear search, and the second one is linear search plus normal binary search in that particular row where the target is present. So how can we optimize it? Is there any other better way? So we have come into the log part of it, right? From n square we have come into n plus log m, right? So can we reduce it further? How do we solve this in order log n into n? So now we can see in the beginning I said that this 2D array can be converted into a single array, right? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. If we apply the whole in that single array, if we have to search any element, so since it is sorted array, we apply a binary search and we can search the element in order log n into n. Can we apply the same logic in this? Can we make this 2D matrix in such a way that we can apply this? So we have all this sorted only now. So if our low is 0 and our high is n into m minus 1, that means 11. So we can find the mid would be the fifth element, 0 plus 11 by 2, fifth element. That means this would be this one, right? If we order it like this 0, 1, 2, 3, 4, 5. So this element is less than 8. So our load obviously increase and low would become this one and high would be this one. Then we will again see. But how do we locate that this is the mid place in our 2D array? It's not a single array, right? That we will directly have the index as the mid. We have to locate the row and the column. So how do we find the row and the column? So now if you see that there are 12 elements in this. So our mid is would be 0 plus 11 by 2 because it's 11. So mid would be 5, right? 0 plus 11 by 2, that is 5. Now how do we locate the fifth index? So we see that in this row there are 4 elements, right? So m is, what is m? M is the number of columns. So if there are 4 elements here, then that means the third and this fifth index element will always be in this first row. And how do we locate the column? So we can locate the row in which the element is there, the mid element is there, just by dividing the mid by the number of columns, right? So what would be 5 by 4? 5 by 4 would be 1. So we came to know that the first column over mid element will be can be there, right? The mid index element. Now how do we find the column? So we'll do mid mod m, right? So that in this row, in this mod m index, the column would be there. So 5 mod 4 is 1. So first row, first column is this. So mid by m gives us the gives us the row in which it is there, and mid mod m gives us the column. So we check the value and then we see it's lesser than the target element. So we'll increase the low to mid normal binary search and we can easily find out using the binary search. The problem just lies down to how do we locate the index in the binary in the 2D matrix for the binary search. So let's code it. So what do we have? We have int. We have actually first we have to find int n. Int n it would be the matrix dot size. That means the number of rows, and int n would be matrix 0 dot size, right? and int low would be 0 and high would be m into n minus 1. So while low less than high, right, so mid would be low plus high by 2. Okay, so in the row you can give as row would be mid by m, or you can just reduce directly and say if matrix mid by m mid mod m row and column is equal to target, return true, else if matrix mid by m mid mod m is less than target, that means we have to increase, it is in this part, so we will increase low is equal to mid plus 1. We will start searching from this to this index, else we will make, if it is, if suppose the element was 4, then this is less, this is greater than the target, right, this 6 is greater than the 4, so in that case we will move over I is equal to mid minus 1, our search will reduce the search to half, and then if we are not able to find in binary search of this, then we will return false, right. So we have solved this in order of log n into m from order of n squared. The link to the question has been given in the description. Please try it yourself and then come to my code walk. Here is the 28th questions code walkthrough section. So searching the target in the 2D matrix, we have discussed this pseudocode for this. So here, so we have already explained this pseudocode. So the same thing we have done over here, and let's submit this directly. So it's accepted. Let me know in the comment section how was the explanation, and see you all soon in the next video where I'll be explaining the 29th question of the problem solving series. Thank you.